Okay, boys and girls, we will do the algebra of functions on this section to start with. So this is all about algebra and composition of functions. Okay, so a couple of things. You can add two functions. It can be written like this. You can add each function. You can subtract two functions to get a new function. You can multiply, and you can divide. Now, the only stipulation on division, of course, is the denominator cannot be 0. Okay, so probably did this in college algebra. To begin with, on this problem, we're given two functions, x cubed plus 3x, and then we're given g of x. And with this one, we're going to find f plus g of negative 2. So to begin with on this, I'm going to go ahead and I'm going to do f of negative 2. So I'm going to plug into the function and do negative 2 to the third plus 3 times negative 2. That'll be negative 8 minus 6. So that is negative 14. Okay, so we're just really doing arithmetic. Then we do g of negative 2. So I do 1 minus negative 2 minus 2 times negative 2 to the second. So that's 1 plus 2 minus 2 times 4. That'll be, looks like 3 minus 8 will be negative 5. Okay, so I'm going to start the problem that way. Finish it up. We just do f plus g of negative 2 is the same thing as just taking f of negative 2 and adding g of negative 2 like that. So f of negative 2 is negative 14. G of negative 2 is negative 5. So you get as your answer, looks like negative 19. Okay. So next problem, start kind of the same way. We'll do g of 0. So we do 1 minus 0 minus 2 times 0 to the second. That'll be 1 minus 0 minus 2 times 0. So that's 1 minus 0 minus 0, so that will give 1. Okay, then I'll do f of 0. So plug into f, we'll do 0 to the third plus 3 times 0. That'll give 0 plus 0, so that is equal to 0. Okay, so again, evaluating functions, you know how to do that. So now when we do f, no, hold on, doing that backwards. Do g minus f of 0, then what we do is we do g of 0, and then we subtract f of 0, which we've already done. So g of 0 is 1, f of 0 is 1, 1 minus 0 is 1, so that would be the solution to that problem. Okay, now we'll go to the next one, dealing with 1/2 this time. So I'll do f of 1/2. Plug that in. I'm going to have 1/2 to the third plus 3 times 1/2. Don't let the fractions bother you. It's not a big deal. If you do this, you're doing 1/2 times 1/2 times 1/2. And when you multiply fractions straight across, you're going to get 1 over 8. And then this would be 3 over 2. Again, you put the 3 over 1 and go straight across. So we need to get a common denominator of 8. Okay, so what I'll do here is I need to multiply this by 4 over 4 to introduce that common denominator. So I get 1/8 plus 12/8. So that gives 13/8 when we evaluate that. Okay, next thing we'll do is we'll do g of 1/2. Okay, so we got 1 minus 1/2 minus 2 times 1/2 to the second. And you could use your calculator on this too. I just like to see students do work with fractions. So we got 1 minus 1/2 minus 2 times 1/4. Again, that's just doing 1/2 times 1/2. Okay, that'll give me 1 minus 1/2 minus 1/2. If you're doing 2 over 1 times 1/4, that fraction just reduces to 1/2. So what I'll get is I'll get 1 minus, and then if I do A half minus a half, that's 2 halves. So that's 1 minus 1, so that's equal to 0. Okay, so we got that done. Now what we do to finish up the problem is we do f of 1 half times g of 1 half. So f of 1 half was 13/8. G of a half was 0. So that means the answer of that problem is going to be 0. Okay. Next problem, we'll do f of 3. So we'll do 3 to the third plus 3 times 3. That's going to give 27 plus 9, so that gives 36. And then we do g of 3. So we have to plug into the function g, which is 1 minus x, or 3, minus 2 times 3 to the second. Okay, so we're doing 1 minus x minus 2x to the second. Okay, that'll be 1 minus 3 minus 2 times 9. So that's 1 minus 3 minus 18. That is negative 2 minus 18, so that is negative 20. Okay, and then to finish up the problem, we just need to divide. So we'll do f of 3, which we worked out, divided by g of 3. To get 36 over negative 20, you could do a decimal, but I'd prefer a reduced fraction. So both of these things divide by 4. So that would be 9 over negative 5. Okay, now you can write this answer several ways. You could write 9 over negative 5, or you could write negative 9 over 5, or you could write negative just in front of the fraction bar. And actually, these two are preferred ways to write that problem. Okay, so that's how you evaluate algebra of functions. Okay, next page we're just going to do algebra problems primarily. So this one we've got these two functions, f and g of x. So when we do this, when we do f added to g of x, what we do is we just do f of x plus g of x. So f of x is given as x squared plus 3x minus 10. G of x is given as x squared minus 4. And really what we're doing is just combining like terms. The parentheses are not really necessary. They're just to show that you have two functions. So you can remove the parentheses and then just combine the like terms. So you would have 2x to the second, when those get put together, plus 3x, that does not have a like term, and then negative 10 minus 4 is negative 14. So you would get as your answer this. Okay. Do g minus f of x. So if we do g subtract f of x, and we have to do this in the same order, we do g of x, then we subtract f of x. So it's pretty similar to the last problem. So g of x comes first, and then minus. Now you do have to have parentheses. That's something that if you don't pay attention to, you're going to mess up. Okay, so now watch how I do this. And sometimes students are bad about messing up here. This is like multiplying that second by negative 1. So you get x squared minus 4 minus x squared minus 3x plus 10. Changing all the signs. Okay, got like terms go together. Looks like the x squareds cancel out. We have negative 3x. And then negative 4 plus 10 is going to be plus 6. Next one, we are multiplying. So if we do f times g of x, we're simply going to take f of x, and we're going to multiply that by g of x. Okay, so if I do this, f of x is x squared plus 3x minus 10. G of x is x squared minus 4. So we have to multiply this out. Okay, so when I do this, we're multiplying. The first thing we're doing is we're doing x squared times x squared, which is x to the fourth. I'm going to write this kind of at the side. Sometimes students benefit if they see what's going on. Okay, then we'll do the next term. We'll do x squared times negative 4, which is negative 4x squared. Okay, then we'll go to the next piece, which will go like this. So we'll do negative 3x times x squared. We'll give negative 3x to the third. Then we'll do negative 3x times negative 4 will be positive 12x. Be sure that you're careful with your signs. And then the last thing we'll do is negative 10 times x squared, which is negative 10x squared. And then finally negative 10 times negative 4, which is positive 40. So see, we're doing 6 multiplications. You have 3 things in the first parenthesis and 2 things in the second parenthesis. So now we look for like terms. So x to the fourth comes down, minus 3x to the third comes down. I'm putting these in a descending order. Like terms on the x squared would give you negative 14x squared. And then we have a plus 12x. And then we have a plus 40. So that's mostly an exercise in multiplying. So x to the fourth minus 3x to the third minus 4x squared plus 12x plus 40. Okay, sometimes it does help students if they write down kind of what I did over here at the side. That can be pretty helpful. Okay, I'm going to just erase that. Okay, and then the next thing I'm going to do on here is we're doing g over f of x. So we just do g of x and we divide by f of x. Okay, so g of x is x squared minus 4. And f of x is x squared plus 3x minus 10. So this is an algebraic fraction. So we need to factor. So the top is a difference of 2 squares. So you have x times x to get x squared. 2 times 2 to get 4. And then you have a plus minus when you factor a difference of 2 squares. Okay, next one goes like this. The first term is x squared, so that would be x and x. The last term is 10, so you're either going to work with 1 and 10 or 2 and 5. And remember, they have to add up to 3. So you're going to use 2 and 5. And if you're going to make 2 and 5 add up to 3, you need to have a plus 5 and a minus 2 like that. Anytime you factor something, be sure to FOIL it and check it. Okay, now you can go ahead and remove that factor of 1. That's just 1. And then you would have as your answer x plus 2 over x plus 5. And x cannot be equal to negative 5. Okay, now the next thing on this is the domain. I just kind of did that on that. Well, the thing is, f of x, we have to kind of be careful about 2 things on this. When you're doing this, you've got the result that canceled out, but there were 2 places where this is undefined, so you would have to say set of x such that x is not equal to 2 and x is not equal to negative 5. Even though the 2's canceled out, in this particular problem, you cannot let x be 2. Okay, so next thing, and I need to add that on there, x can't be 2 also, even though it cancels out, so you have to be kind of careful about that. Okay, so next page, we'll go ahead and have you try these. Pause the video and check your answer when you're ready. Okay, so if you want to check the answers on this, you can take these and take a look at these. Negative 21, negative 48, negative 474. The last one, since you can't divide by zero, is undefined. Okay, so it's all arithmetic. So if you made any mistakes on that, pause the video and get those corrected. Okay, so to wrap up this video, then go ahead and check your answers on this. There's a couple things I do want to go through. I think the first two pretty straightforward for students. Make sure on this first one that you remove those parentheses correctly. That's a real common mistake, so all the signs change. Minus 2, plus 3, minus 5. Number C, you're really foiling. Okay, you're doing 4x squared minus 25 times itself. The last one probably has the hardest thing. I do want to kind of go over and talk a little bit about the factoring on this, because that's a bit of a challenge for a lot of students. So when you factor this trinomial, I usually do this with a trial and error type of method. So that first term is the only two things that multiply to give 2x squared are 2x and x. So write it down. You can't do this problem in your head. You have to kind of try it a little bit. Then your last term are just numbers that multiply to give a 5. There's only two choices, and the order makes a difference. If I did it like this, then what you want to do is just look at the inner term. 1 times x is 1x. 2x times 5 is 10x. And you're trying to make that add up to negative 3x, so that doesn't work, obviously. Okay. So what I'm going to do is I'm going to try it the other way. So I'm just doing this by trial and error. I'm not doing factor by grouping or anything like that. You can do whatever you want to, but it's easier this way. So I'll put 5 and 1 in. It's less work this way. So that's 5x. Outside term 2x times 1 is 2x. Question becomes, how do I make those two things add up to negative 3? Well, I accomplish that if the 5's negative and the 1 is positive. Okay, and that's how that goes. And then the next one's a difference of two squares. You have to understand that 4x squared is a perfect square because it's 2x times 2x. 25 is a perfect square because it's 5 times 5. So anytime you have a difference of two squares is your factoring problem, you just do the 2x times 2x. You don't do 4x and x, just what times itself gives you that. 5 times 5. And then a plus minus. The reason there's a plus minus is because the inner and outer terms cancel out. There is no middle term on that. Okay, so you have to do that. The other thing I wanted to mention on this problem is after you cancel out, well, what you have to do is to get this domain, you have to look not at just the 2x plus 5, but you got to look at both factors. So I set both factors equal to 0 to conclude that I can't have an x value of negative 5/2 or 5/2. That's how that works out. Okay, that will wrap this part of the video up, and then I'll do a second part for composition of functions. Hopefully this helped you a little bit. Mostly college algebra review. Good luck.